Welcome back to Chapter 17. We're in Part 2, Inferences about a population mean when we don't know the population standard deviation. We're going to continue with a little review from the last time. I want you to find the critical values, but given to you in a different way. If I say find the critical value when alpha is 0.05, what confidence level are we talking about? We're talking about a 95% confidence interval. And for an alpha of 0.01, we're talking about a 99. So go on and find the critical values given these alphas. So in other words, find these critical values for a 95% confidence interval with these different degrees of freedom and a 99% confidence level for these different degrees of freedom. So please stop the tape and make sure that you can get the answers that are going to appear in another second. So this is the answers to those questions. Now, as you see the one that says 31, when you looked on your critical value chart that's on Blackboard, I'm going to pull it up and you're going to see that it doesn't have 31. What our convention will be is you go to the next closest degrees of freedom. So as you can see, I didn't have 31, but I went to 30. So let's say that I had 56. I would then go to 60 to find that. And let's say that I had 329. I would go to 100 degrees of freedom. So let's look at, for 95% confidence intervals, different degrees of freedom. And let's look at the critical value that goes with them. Now for a standard normal table, we know that the critical value is 1.960. Now look, if we have a degree of freedom of 4 that came from a sample of 9, our critical value is 2.306, very different from 1.96. But look what happens as our degrees of freedom increase. The number gets closer and closer to the critical value that we find for the standard normal table. So let's look at the 95% confidence interval. We know that. Or let's look at the 99% confidence interval. It's more dramatic. We know from our standard normal table that it's 2.575. But look down here at the very last line where you see the Z star for the critical value for a 99% confidence interval. More accurately, it is 2.576. So from now on in, when you want to find critical values for your Z, the standard normal distribution, if it happens to be any of these confidence levels on this table, 50, 60, 70, 80, 90, 95, 96, 98, 99, 99.5, 99.8, or 99.9, you have the critical values right there. But let's take a look at the 99% confidence level. And as our sample size increases, let's look at those numbers. If we have 2 in our sample, that gives the degree of freedom of only 1. For the 99% confidence interval, look at what the critical value is, 63.66. You get a very large confidence interval. In other words, the length of that confidence interval is going to be huge. But let's look at a sample of size 19. The confidence, the critical value is 2.861. And as we keep going on, that's drastic change from 60 to 2. Keep going down to 80, the critical value for a 99% confidence interval is 2.639. And then look at what our critical value for standard normal, it's 2.576. You can see that the numbers converge or get very, very close to the standard normal. And that just shows you as our sample size increases, these t-distributions look more and more and more and more like the standard normal table. So let's look at the properties of confidence intervals. Most of these will just be a repeat that you would already know. As the sample size n gets large, there's less and less of a difference between critical values for the normal and the critical values for the t-distribution. We just saw that. We went through that example. It's correct to use the t-distribution when our population standard deviation isn't known. With technology, we should always use the t-distribution. When doing rough assessments by hand, the normal critical values can be used, particularly if n is large. For example, if n is 30 or more. Now, when does that t distribution and the normal distribution differ a lot? We already saw this when the sample size is very small. You see those numbers are very different. And when the confidence level needs to be very high, particularly if we have alphas of 0.005 or higher. So here's our one sample t confidence interval. We have to take a simple random sample of a certain size from the population with a known mean and an unknown standard deviation. A level C confidence interval looks like this for our sample population mean. So it looks very similar to the confidence interval, a Z interval, except for we would see a Z naught and instead of S, sigma. So let's look at an example of how we would use this. We're looking at a problem where we have a simple random sample of 7 American adults. They have an average height, these 7 in our sample have an average height of 67.2 inches with a sample standard deviation of 3.9 inches. They want us to construct a 95% confidence interval. And look, we have our sample mean plus or minus our critical value, and then times our sample standard deviation divided by the square root of n. With a critical value for a 95% confidence interval, but how many degrees of freedom do we have? 6. So that's where that 2.447 comes. Looking at the chart, a 95% confidence interval with 6 degrees of freedom, it intersects at 2.447. That's our critical value. Please don't forget to subtract your sample size by 1 when finding these critical values. It's very easy and common mistake to make. When you do the math out, you get that confidence interval. And there's the two different types of interpretations you could use when you interpret it. And you'll need to know that for your Minitab, and we'll be going over Minitab. I'll have a Minitab help up online soon. Now let's look at another example, the rare fish example. Assume that we want to estimate the average weight of a particular type of very rare fish. The weight of the very rare fish is known to be normal. We are only able to borrow 7 specimens of this fish, so we take a simple random sample of 7 fish. The average weight of the sample was 1.38. That's our X bar. The sample standard deviation was 0.29 kilograms. That's S. They want us to construct a 95% confidence interval for the true mean weight. Please stop the tape, and with this information, build your confidence interval. So our critical value for this is 2.447. The sample mean is 1.38, and the sample standard deviation is 0.29. All of these given by what they asked and what was given in the problem. Putting them into the formula and doing this by hand, you would just use your formula X bar minus our critical value times the standard error. We just add the critical value times the standard error. And we now have the interpretation. We estimate that the average weight of this rare fish is between 1.11 kilograms and 1.65 kilograms with a 95% confidence interval. Now, if I wanted to do this in Minitab, here's the command that you would use in Minitab. It's called the 1T command because we have a 1 sample, and we're going to use the T distribution. So 1T. And then you have to give it the N, the sample size, the X bar, sample mean, and then the S, the sample standard deviation. You put a semicolon because now you have to tell Minitab what your confidence level is, and our confidence level was 95. When we hit enter, it will give us the confidence interval, and there we have it. It's exactly what we did when we did it by hand, just a little more exact. So here's the generic Minitab command and what you need to put in, and you need to put it in the order that it is specified here. Now, if our data is in a column, so we're not giving a summary statistic, so we're not given X bar or S, but we have the raw data in a column, this is the Minitab command that you would use. You would say, do a 1T, my data is in CY, and Minitab will calculate the N, well, it will get the N, it will calculate the X bar and the S for you. Now note that in this class we will not expect you to have to ever calculate a sample standard deviation. We'll give it to you, or we'll give out a Minitab, give you a Minitab output, and you can get the sample standard deviation off the output. So make sure that you can read the output